fuels. A thermodynamic textbook is not the place for a detailed treatment of fuels. However, some knowledge of them is prerequisite to a consideration of combustion, and this section is therefore devoted to a brief discussion of some of the hydrocarbon fuels. Discussion of some of hydrocarbon fuels. Most fuels fall into one of three categories: coal, liquid hydrocarbon, and gaseous hydrocarbon. We have three categories for coal, liquid hydrocarbon, and gaseous hydrocarbon. Most fuels fall. Coal consists of remains of vegetation, deposits of past geologic age after subjections to the biochemical actions, high pressure, temperature, and submersion. The characteristics of coal will vary considerably with location, and even within a given mine there is some variation in composition. A sample of coal is analyzed on one of two bases. The proximate analysis specifies on a mass basis the relative amount of moisture, violet matter, fixed carbon, and ash. The ultimate analysis specifies on a mass basis the relative amount of carbon, sulfur, hydrogen, nitrogen, oxygen, and ash. The ultimate analysis may be given as received basis or on a dry basis. In the latter case, the ultimate analysis does not include the moisture as determined by proximate analysis. A number of other properties of coal are important in evaluating a coal for a given use. Some of these are the fusibility of the ash, the grindability of ease of pulverization, the weathering characteristics, and size. And most of liquid and gaseous hydrocarbon fuels are a mixture of many different hydrocarbons. For example, gasoline consists primarily of a mixture of about 40 hydrocarbons, with many others present in very small quantity. In discussing hydrocarbon fuels, therefore, brief consideration should be given the most important families of hydrocarbons, which are summarized in this table. Characteristics of some of the hydrocarbon families: paraffin, olefin, diolefin, naphthalene, aromatic such as benzene and naphthalene, with the appropriate formula and structure described in this table. Three concepts should be defined: The first pertains the structure of the molecule. The important types are the ring and chain structure of the molecule. The important type are the ring and chain structure. The difference between the two illustrated in this picture between ring and chain structure. In the chain structure we have saturated and unsaturated structure. An unsaturated hydrocarbon has two or more adjacent carbon atoms joined by a double or triple bond. Unsaturated has two or more adjacent carbon atoms. Are joined by a single bond. Has two or more adjacent, joined by a double or triple bond. Whereas in a saturated hydrocarbons, and on the other hand, we have saturated, also shown in the picture here. For the saturated case, hydrocarbons, all the carbon atoms are joined by a single bond. The third term to be defined is an isomer. Two hydrocarbons with the same number of carbon and hydrogen atoms and different structures are isomers. Let me two hydrocarbons with the same number of carbons and hydrogen atoms are joined by a single bond. The third term to be defined is an isomer. Two hydrocarbons with the same number of carbons, let's say this, there are several different octans, each have 8 carbon atoms and 18 hydrogen atoms, but each with a different structure. For example, there are several different octans C8, H18, each have 8 carbon atoms and 18 hydrogen atoms. But each with a different structure. The various hydrocarbon families are identified by a common suffix. The compound comprise the paraffin family, all end in "ane". Paraffin families end by "ane", such as propane, octane. Similarly, the compound comprising the olefin family with the elen at the end, for example, or propane, propylene, and the olefin family ends D. butadiene, the naphthalene family has the same chemical formula as the olefin family, but has a ring rather than a chain structure. Has same chemical formula as the olefin family, but has a ring rather than a chain structure. The hydrocarbons in the naphthene family are named by adding the cyclo as the cyclopentane. Cyclo, for example, cyclopentane. The aromatic family includes the benzene series and the naphthalene series. Aromatic family includes the benzene, or the naphthalene series. The benzene series has a ring structure and is unsaturated. Most liquid hydrocarbons first are mixture of hydrocarbons that are derived from the crude oil through distillation and cracking process. The separation of air into two major components, nitrogen and oxygen, using a distillation column was discussed briefly in the previous chapter, Chapter 1, Part 5. In a similar but much more complicated manner, a fractional distillation column is used to separate petroleum into its various constituents. Distillation columns separate air into two major components. Nitrogen and oxygen. Using a distillation column was discussed briefly previous. A fractional distillation column is used to separate petroleum into the various constituents. This process is shown schematically in this picture. The fractional distillation column. Figure 15. Two liquid crude oil is gasified and enters near the bottom of the distillation column. The behavior fractions have higher boiling point and condense out at the higher temperature in the lower part of the column, while the lighter fractions condense out at the lower temperatures in the upper portion of the column. Some of the common fuels produced in this manner are gasoline, kerosene, jet engine fuel, diesel fuel, and fuel A. Let me write some of the common fuels produces in this manner. For example, gasoline, kerosene, jet engine fuel, diesel engine, fuel, diesel fuel, and fuel oil. Alcohols presently see increased usage as a fuel in internal combustion engine are a family of hydrocarbons in which one of the hydrocarbon atoms is replaced by OH radical. Alcohol fuel in combustion engine are a family of hydrocarbons in which one of the hydrogen atoms replaces OH. Does methyl alcohol or methanol methyl alcohol or methanol is and ethanol is one of the class of biofuels produced from crops or waste matter by chemical conservation process. There is existing research and development in the area of biofuels at the present time, as well as in the development of processes for producing gaseous and liquid hydrocarbon fuels from the coal, oil shale, and tar sand deposits. Several alternative techniques have been demonstrated to be feasible, and these resources promise to provide an increasing proportion of our fuel supplies in the future years. It should also be noted here in our discussion of fuels that there is currently a great deal of development efforts to use hydrogen as a fuel for transportation usage, especially in connection with the fuel cells. Liquid hydrogen has been used successfully for many years as a rocket fuel, but is not suitable for vehicular use, especially because of the energy cost to produce it, as well as serious transfer and storage problems. Instead, hydrogen would need to be stored as a very high pressure gas or in a metal hybrid system. There remain many problems in using hydrogen as fuel. It must be produced either from water or hydrocarbon, both of which require a large energy expenditure. Hydrogen gas in air has a very broad flammability range. Almost any percentage of hydrogen, small or large, is flammable. It also has a very low ignition energy. The slightest spark will ignite a mixture of hydrogen in air. Finally, hydrogen burns with a colorless flame, which can be dangerous. The incentive to use hydrogen as a fuel is that its only product of combustion or reaction is water. But it is still necessary to include the production, transfer, and storage in the overall consideration. For the combustion of liquid fuels, it is convenient to express the composition in terms of a single hydrocarbon, even though it is a mixture of many hydrocarbons. Thus, gasoline is usually considered to be octane, and diesel fuel is considered to be dodecane. And for diesel, 26. The composition of hydrocarbon fuel may also be given in terms of percentage of carbon and hydrogen. The two primary sources of gaseous hydrocarbon fuels are natural gas wells and certain chemical manufacturing processes. This table provides the composition of a number of gaseous fuels. The major constituent of natural gas is methane, which distinguishes it from manufactured gases. This table shows various natural gases consume methane. Various natural gases produce gas from bituminous coals and other properties. For various volumetric analysis of some typical gaseous fuel. The next section is the combustion process.